In this nugget, we get to discuss several ingredients that go into the recipe for a load balancer from Citrix. Specifically, virtual servers, which we're going to bind to services, and those services which are bound to servers. We're also going to use a monitor function just to verify that these servers are actually up and available to provide those services. Let's begin. I'd like you to think back in your mind about the last time that you had a really great meal. I'd like you to think about how it looked, how it smelled, how it tasted, and also realize that with that meal, it was no accident that that came together that way. There was a recipe that was followed, there were certain ingredients that were used. The first item I'd like to talk with you about is a virtual server. Now, this virtual server is just a logical representation of some type of a server. Now, this virtual server, which I'm going to go ahead and put here in black, I'm going to name it virtual server. When we create that, we're going to give it a name. We could call it Bubba, we could call it acme.com, we could give it a name in the NetScaler, and then we also tell it what protocol this virtual server is going to be prepared to service. For example, HTTP. We'll specify the virtual IP address that this virtual server should respond to. And in our topology here, we're going to use a VIP, a virtual IP address with the virtual server of .201. And we'd also specify a port. Now you might be saying, well, Keith, the HTTP, the default port is 80, and that is very likely the port we would use. However, as we configure our virtual servers, if we have circumstances that are using non-standard ports, we can specify those exactly what we want this virtual server to support as we define that virtual server object. So at this point in our story, with just the virtual server defined, if Bob sent an HTTP request to that address, the NetScaler would be in trouble. Because although the virtual server knows that it's supposed to support HTTP, it knows the IP address and the port, it has no example, we could create a service called our HTTP service. And in that service object, we would identify what the real server is over here that's actually running that service, the protocol, in this case it would be HTTP, and the port, which also would be 80 in this example, if these were all web servers. And the magic is we are going to bind the virtual server to a service. So we're one step closer. The virtual server now knows of a service, and that linking, that gluing of a virtual server to a service is called binding. So a virtual server, if it's not bound to a service, really doesn't have much to offer Bob when Bob's requests come in. Now also, to complete this picture, we also need to identify our real servers in the NetScaler. So on the NetScaler itself, we're also going to have server objects. And the server objects are going to be given names in the NetScaler configuration. And as part of that configuration, we're going to point to a server. So if we have 3 real servers, we'd very likely have 3 server objects. One pointing to the IP address or DNS resolvable name of server 1, another server object pointing to server 2, objects. And service objects are bound to server objects, which represent the servers that are hosting those applications or services. So if we did a mini drawing of this over here, we'd have the virtual server, and we could have 3 service objects that are all for HTTP, and each of those service objects and the cool thing is, the decision about which one to forward off to can be done based on lots of factors, such as round robin. So the first request goes to this one, then the second request goes to this one, third request goes to this one. And again, the virtual server is To assist the virtual server in not making a bad choice, there is another component called a monitor that's added to the mix. So this triangle, this red triangle, is representing a monitor function. And that monitor is doing a health check on those respective servers. And the binding, if you will, is between the service object and the monitor. So because each of these monitors are periodically checking the health and welfare of their servers, if server 3 goes down, the monitor is going to say, hey, this server isn't up. This service number 3 would go ahead and be shown as down. And as a result, the virtual server wouldn't choose that service as an option for load balancing because the service is being reported as down, which represents server 3 being down. However, if these two HTTP services are still up, the virtual server can still load balance the HTTP against those two HTTP service. I appreciate you joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.